So what you missed in class today, I will explain to you in this video. Once again, we are continuing to work with angles within triangles. So our first problem, we want to find all of the labeled angles and also what angle A plus angle D would be. Now, since this triangle is in a circle, we hopefully see all the different radii in the circle. We have one here, here, and here. So, starting where we have information, what kind of triangle is this? It is an isosceles triangle, which means that the angles across from your congruent sides are your base angles. So down here is 25. Our other base angle has to be 25. So that means that angle A equals 25. To find angle B, you would add your two angles and subtract them both from 180, and that would give you 130. So angle B is 130. So now we need to find C, D, and E. So angle C is an exterior angle to the 25 angle and the other 25 angle. So our exterior angle theorem tells us the exterior is equal to interior plus interior. So C is going to equal 25 plus 25. So angle C is equal to 50. So now looking at the other triangle in our picture, where angle C was 50, so we now have that angle right there. This is also an isosceles triangle. So our base angles across from the congruent sides, we'd have one here and over here. So that means that both of those angles have to be the same. If you want to call them both x, you can to help you solve. So that means that x plus 50 has to give you 180. And solve. And you get x is equal to 65. So that means that we'd have 65 degrees here and also here. So angle D is 65 and angle E is 65. So we also want to know what angle A plus angle D would equal. So angle A was 25 degrees and angle D was 65. So that means that angle A plus angle D is going to equal 90 degrees. Okay, so moving on to another example. Once again, in this picture, we want to find the labeled angles, angles A through E. So, starting in the triangle that has some information given, this is 100, and by the tick marks, we know that this is an isosceles triangle. If this is my congruent leg, then I have a base angle over here. Congruent leg, base angle down here. Both of those angles have to be the same. So you could say that 2x plus 100 has to give you 180. So that means that both of those angles are 40 degrees. So we want angle A, B, C, D, and E. And we just found C and D. C and D are both 40 and 40. So from here you might get a little bit stuck of where you should go next. What's important is to see that the outside triangle has all three of the sides marked off as congruent. So that means that the outside triangle is equilateral. And since it's equilateral, all the sides are the same and all your angles equal 60 degrees for an equilateral triangle. So that means that all of your entire angles for the equilateral are 60 degrees each. So that means up there, the only whole angle is 60 degrees. So angle A is 60. Now, we need to find angle B and angle E. What can help us here is remembering that this was 40 degrees and this was 40 degrees. So what we kind of see happening is that this whole corner angle is 60 degrees. We know where C was is 40 degrees, and we want B. So to find B, you would take the whole and minus the part. So that means that B is 20 degrees. And now to find our last angle, angle E, we're going to follow that same kind of idea. This whole corner angle is 60 degrees. We know that the bottom part of it, where angle D was, is 40. To find angle E, it would be the whole minus the part, or 60 minus 40. So angle E would also equal 20 degrees. Okay, so now this is our third example, and we're told that segment BD is an angle bisector to angle ABC. And we need to find angle X, Y, Z, and W. Alright, so what's important here is to see that we have a set of parallel lines. And within those parallel lines, this angle right here is 55 degrees, which would be here. And I'm drawing this transversal with those parallel lines. So from 55 to where angle Y is, those are corresponding angles. And we know that corresponding angles are congruent. So that means that angle Y is 55 degrees. So once again, we want to use those parallel lines. So I'm going to draw them outside of the picture. Now, we have 55 here, and we know that BD is the angle bisector. That's what I said in the beginning. So that means angle bisector to angle A, B, C, that this angle gets split in half. Bisector means split in half, which means if it's split in half, both sides are the same, and angle Z is 55 degrees also. Now with our parallel lines, if I draw this transversal line in, if I have 55 degrees here, where that one was, then where angle X is labeled, those two angles are alternate interior angles. And we know the alternate interior angles are congruent. So that means that angle X has to be 55 degrees also. So now to find angle W, I'm going to use this triangle. So that's what I just drew outside of the picture, where this was 55 and angle X was 55 also, and this is where W is. So that actually means that this is an isosceles triangle, and that W plus 55 plus 55 has to equal 180. So W plus 110 has to give you 180, and W is going to equal 70. So W is 70 degrees.